The second speaker, and then you will take over from there.
I was like wondering, why am I speaking first?
Yeah. Okay. Okay. Good afternoon. Can you hear me? Yes. Good afternoon, ladies and gentlemen. Please have your seats. So in the coming hour, we are going to discuss a very important subject, air pollution, its effects on the lung health and TB risk. It's an important subject globally, and both as a risk factor in the household and ambient. Our first speaker is Professor Jonathan Gregg. He is a professor of pediatrics at Queen Mary Hospital.
Thank you very much, Asma. Thank you very much for the kind invitation to come to Mexico for the first time. I'm going to talk about what I think is a really important link between inhaled toxins and vulnerability to bacterial infection, especially pneumococcal infection. And this is what we're talking about, the pneumococcus, which, as you know, is the major cause of bacterial pneumonia in young children, but also in adults, and a cause of very serious invasive disease in some adults as well, and in some children. And this results in pneumonia. This is a child admitted to our ward who has got the classic pneumonia and an empyema with fluid between the lung and the chest cavity, and we've inserted a drain to drain off the pus, and we treated this child with penicillin, and it got better, completely better, and we discharged it. So why do you get infected with the pneumococcus? Well, the idea is that you inhale the pathogen into your nose and possibly into your airway, and to create disease, that pathogen, the pneumococcus, has to get a niche. It has to somehow evade the host responses and stick to the airway cells, the lining cells. Without that, disease is not possible, and certainly invasive disease is not possible. You have to have the adhesion of the bacteria to the lining cells before you can develop the disease, which is mainly a lower airway disease. Now, we know from epidemiological studies that a variety of inhaled toxins increases vulnerability to pneumococcal disease. Smoking, for example, has been known for some time, has been associated. This is published in 2000, compared to never smokers. Current smokers, a four-fold increase in risk of invasive pneumococcal disease, and adults who are exposed to passive smoke, a significant increased risk as well, twofold. We know also in children exposed to passive cigarette smoke, and this is a study from Vietnam published in Thorax, that those children will have an increased risk of pneumonia. Most of that will be pneumococcal pneumonia. And because it's so prevalent, exposure is so prevalent in Vietnam, the population attributable fraction is over 25%. So if you remove passive smoke exposure from that population, this would predict you would reduce your rates of pneumonia by 25%. Now, we talk about air pollution. We've had many talks about this. We've got a complex mix that we're breathing outdoors, including a variety of gases, nitrogen dioxide, but our focus mainly is on these particles, particulate matter, so mainly sooty particles onto which a variety of toxins are attached. Now, we know also from epidemiological data, and this is from the big ESCAPE study, which had a variety of European cohorts which were merged together, exposure to fossil fuel particles less than 2.5 microns. These are very small inhalable particles, were modeled for children's address, and there was a significant risk of pneumonia in the first 2 years. So we're having a sort of a theme of what you inhale. If it's a toxin, it seems to be associated with increased risk of developing pneumonia. Now, these are the particles we're talking about. Here I've stuck a little tube outside my laboratory, sucked it in. These are London particles, and these are little carbon spheres of carbon, each sphere is only about 10 nanometers in diameter. They form aggregates which are still very small, less than 25 microns, 2.5 microns, so it can evade the nose and get down into the lower airway. But if you are designing something that gets to the lower airway and stays in that lower airway, you couldn't do better than the fossil fuel particle. Here's the soot, the carbon onto which all these toxins are absorbed. Now, the point about particles is that a proportion stay in the lung. So these toxins can be leached off the carbon core over long periods of time, and we really don't know the mechanisms associated with this sort of toxicity. Of course, with biomass smoke, it's associated with particles and other things. We also see an effect. This is a meta-analysis for pneumonia under 5, and we're having significant effects for odds ratio 1.78 for exposure to biomass smoke. So again, this consistent effect of whatever you inhale, if it seems to be a toxin and it's from combustion derived, you're going to get an increased risk of pneumococcal pneumonia. And of course, that is the driver of these statements about the causes of death and exposure to biomass. Now, what about making the link between the epidemiological data and the mechanisms? So the first question we have is, well, do sooty particles get down deep into the airway and could potentially influence vulnerability to infection? So these are diesel exhaust particles, very smoky diesel exhaust. And we've been looking at cells coming from the lower airway. We get kids to breathe, I'll just move back. We get children to breathe a salty mist that encourages cells to come up and cough them out, and we look at them. So these cells are macrophages. They can only exist in the lower airway, and these are macrophages from a child who's lived in London, and you can see these little spots of carbon. So this is carbon soot from predominantly diesel, which has accumulated in these cells. And if you look at that, you can see this isn't something that's manufactured by the body. This is really diesel soot. In biomass-exposed populations, we see the same effect. This is a study we did in Gondar in Ethiopia some time ago. We did, again, breathing the salty mist and looked at the macrophages, and you see much higher levels of carbon loading of these cells. And of course, that is consistent with the fact that these children and women are exposed to much higher levels of carbon particles. In fact, this is just to show the difference between a UK adult population and Ethiopian women, Ethiopian children and UK children. Big differences. The area of carbon, the amount of carbon in the cells, which we measured using image analysis. And of course, we know that because this is a study where a biopsy shows carbon in macrophages and in the tissue as well, throughout the tissue in an individual who exposed to biomass. So the stuff that we're seeing in the cells coughing up, that's good. That means it's removed, but that means that particles are getting to other parts of the lung as well, the lining, for example, and getting behind those cells. We've done a little study in Malawi associated with the cook stove intervention. We wanted to see if women who were exposed to the advanced cook stove would have less carbon, so we did that. We see here women very high levels of carbon loading as opposed to some of the UK women. And in this very small study, we found differences between the intervention and the improved cook stove did seem to be associated with lower carbon, but there's a big degree of overlap there, which suggests that exposures to smoke were occurring at other parts. But again, this is the levels in London, which we'd be concerned with, are actually very, very low compared to that biomass group. Interesting enough, we see in some women sheets of bacteria in their airway. This is from Malawi. We don't really understand that. We never see that in normal women in the UK. So what about mechanisms? How could particles increase the risk of pneumonia? This is the question. It's a very complex system. But one thing that we've focused on is this adhesion event. This is the stickiness of bacteria to the cell wall. And what the what is the pneumococcus use to stick to cells is this receptor. It just happens to use it. It co-opts it. It uses it as a Trojan horse. It just happens to be able to stick to that receptor. It's called the platelet activating factor receptor, PAFR. And it's this is an interaction between that and it cannibalizes that receptor. So this is the idea, is that we've got the bacterial cell wall, it interacts with that receptor so that the pneumococcal could anchor to the cell. So if you have upregulation of this receptor, more bacteria will stick to the airway cells and increase potentially the risk of infection. We know in mice who've knocked out that receptor, they survive much better than mice who have the receptors. This is a knockout mice. So it does suggest that the receptor is functionally relevant in the complex animal. So what we've done is just take human airway cells, we add particles to them, we wash those particles off, we add strep pneumoniae, wash them off, and then we assess the number of bacteria. And then we stimulate those cells with a variety of toxins beforehand. So this is an airway cell where we have the particles stuck to that before we washed it off. This is showing that the particles on airway cells, this is the lining cells of the lung epithelial cells, actually get into the cells themselves. This is the bacteria stuck to the airways, to the airway cells, and this is the combined effect. We've had bits of particles here that are stuck after washing, and there's the bacteria which we're looking at. So the more bacteria we have, the more adhesion there is. So in our study here, we looked at urban particles from Ghana, Accra, and the UK, and we looked at the amount of adhesion. So the more bacteria we can grow from the cells, the more adhesion there is. And here we see significant effects of UK particles and particles from Ghana, although they seem to be less stimulatory in this assay. Just using a fluorescent assay, we see particles stimulate more bacteria. So here we use fluorescent bacteria, so we see that effect here. And this is a complicated slide, but just I'd like to focus on here. Here are cells exposed to particles, and here are cells exposed to particles and a PAF receptor blocker. So you can actually block that adhesion completely using a blocker of the PAF receptor. So this PAF receptor seems to be really important. We've seen the same effect with cigarette smoke extract. Particles are increased. Sorry about this. This is something that's happened here. But we see an increase with cigarette smoking extract. So we think the platelet activating receptor is a very useful receptor. It's used by pneumococcus. Various things upregulate it, including these pollutants, but other things like viruses, aging, even sickle cell disease is associated with that. And some things downregulate it or block it. The blockers that we used, but also statins can do that as well. Some new evidence, we've been just looking at a new emerging pollutant, I would say, e-cigarettes, which is widely used in the UK because we have a very, we don't regulate them very excessively. And with e-cigarette, with nicotine-containing vapor and nicotine-free vapor, we see effects on adhesion over time. So we do see nicotine vape, nicotine-free vape even stimulating adhesion. And this is vapors who we have measured their nasal expression using nasal biopsies before vaping and after vaping, and we see significant increases, although this individual didn't increase. In biopsies from smokers, we see increased PAF receptor expression in the lower airway. This is the brown versus normal non-smokers. These are so-called healthy smokers who don't have COPD, and this is a healthy non-smoker using bronchial biopsies. And finally, the question there is, could we use these receptors as a biomarker of some way of exposure? And we've got some preliminary data where our laboratory workers have walked in Oxford Street. If you know London, it's a very polluted street. You can buy things there which are of interest, but it's a very polluted street. And then going into our institute here, which is very clean, or going from the institute and walking in Oxford Street. If you monitor these individuals, this is a single go with a black carbon soot. We see someone in Oxford Street, high levels of soot, low levels in the institute, low levels in the institute, and high levels in Oxford Street. And using repeated biopsies, we see evidence that you have higher levels of expression which fall as you move into the less polluted environment and then increase as you move from a less polluted environment to a high level. This is one person. We will need to show this obviously in a larger group of individuals. So, yes, to summarize, I think the association that we see robustly between exposure to inhaled pollutants of a variety, so biomass, cigarette smoke, and fossil fuel-derived particles, the association between that and vulnerability to pneumococcal pneumonia, especially in young children, is supported by some of the mechanistic studies that we're doing. We think that modulation of adhesions, so the capacity of airway cells to support bacteria sticking to them, is one mechanism. It may even be a key mechanism, but it clearly isn't the only mechanism. And we think that using our little nasal biopsies, they're very non-invasive, they don't cause any pain, they're but you can get a lot of information from them, from airway cells, you can grow the cells, you can look at flow cytometry, you can look at transcriptomics in very small levels of cells. We think that nasal, this sort of a way of biopsying the nose is a nice way of assessing vulnerability to infection. So it would be very interesting to know what is the PAFA expression in, let's say, biomass-exposed women compared to non-biomass-exposed women. Thank you very much.
Okay, we can take one or two questions to Professor Gregg. Yes, please, Matt.
Jonathan, can you comment on whether the mechanisms you're observing related to pneumococcal infection would be relevant to TB risk?
I don't know. I don't think that that Mycobacterium tuberculosis uses the same sort of mechanism that it gets into macrophages and hangs around. So this adhesion event may be important in the macrophage, and I don't know about the interaction into TB, but we should say there are other bacteria which do use this interaction. One is the meningococcus, or some forms of the meningococcus, so that may be interesting because cigarette smoking is associated with vulnerability to meningitis and various other things. So we haven't used meningococcus in our assays. We will be using that. And non-typable Haemophilus also uses that. So yeah, TB, I think I'd have to ask the experts about what adhesion mechanisms are involved. I would guess it's not PAFR, but it could be some other receptors.
Thank you. Okay, if no more questions, we'll move to our next speaker. Thank you very much, Professor Gregg. And our next speaker is Associate Professor William Shackley from Johns Hopkins, and he will talk to you about air pollution and other environmental factors associated with lung function.
Well, thank you very much to the organizers for inviting me to speak. And my talk is going to focus on air pollution and effects on lung health. No conflicts of interest. I just wanted to say that our work is mostly funded by the National Institutes of Health, and more recently, trials on household air pollution are funded by NIH, the Gates Foundation, the Global Alliance of Clean Cook Stoves, and work that we're doing on COPD by the Medical Research Council. So I'm going to bring two topics. I'm going to discuss the topics with you. One is the role of biomass fuel smoke as a risk factor for lung function deficits, both cross-sectionally and longitudinally, and also discuss other environmental factors that may also be associated with accelerated lung function decline. So to you all, this figure is quite familiar. This is the classic Fletcher-Peto diagram that shows that after age 25, we are all dying, and we're dying slowly because we're losing lung function at a rate of about 25 milliliters per year. And if you smoke, and if you're susceptible to smoke, which is about 10 to 15% of the population, and it highlights this gene by environment interaction, your lung function is accelerated, your function decline is accelerated to the point where you're losing anywhere from 50 to 60 mLs per year. But more recently, there's in work done by by Peter Lange, it was published about 2 to 3 years ago, has put a big emphasis on how the trajectories of lung function decline can start very early on. So we know that some of these effects can actually start in utero or very early at birth and make modifications to your lung function trajectory over the life course, such to the point where you're not reaching your full lung potential by age 25 years of age, and as a result could have, there are different pathways as to how one develops COPD. And similarly, I think there's many risk factors that kind of play a role in potentially affecting your ability to reach your lung function potential. So when you think about it in fetal development, could be malnutrition of the mother, it could be micronutrient deficiencies of the mother. We know that smoking during pregnancy does it, and we're currently, we and others are exploring how biomass fuel smoke has effects in utero and lung function development. Childhood and adolescence, there's also, in adulthood, there's a whole series of different exposures throughout the life course that can lead to much lower lung function or lung growth throughout the life course. So I wanted to focus initially on biomass fuel smoke, and this is a pervasive, gross exposure. Here's a picture of a home in our setting in Peru. You can see a woman cooking with a traditional open fire stove. And what strikes me the most about this is just kind of the grossness of the exposure. You can see the haze in the room. And the exposure is so gross that you can actually see the soot that forms all around the walls of the house and even forms stalactites in the ceiling. So this is a pretty significant exposure. And as you know, this is a problem that is worldwide. About more than 40% of the world uses biomass fuel smoke, biomass fuels to cook. And it explains about 5% of the global burden of disease. It's about 100 million disability-adjusted life years lost. And it's ranked as kind of number 3 in kind of the risk factors after high blood pressure and cigarette smoking. We know that this is actually work done by Rogelio's group, who's here, kind of discussing. This is a study that looked at autopsy of lungs of people who are being exposed to either biomass fuel or tobacco smoke. And one of the things that came out of this is that the kind of lung tissue of people who were exposed over time to biomass fuel smoke showed much more fibrosis and scarring than it did in cigarette smoke. And this is work that was done in a group of mice in which they were exposed to either normal air, cigarette air, or biomass smoke. And one of the things that you find is that you can actually even see the deposits of biomass all the way down into kind of the alveoli. This is what this group found. And there was a lot of lymphocytic inflammation around the arterioles. So we know that there's a good amount of observational evidence that has linked the use of biomass fuels with chronic obstructive pulmonary disease. And looking at meta-analyses of multiple studies, one can see that the odds of having COPD if you use biomass fuels is about 3 times higher. And it's the same for chronic bronchitis. It's about 2 to 3 times higher if you're using biomass fuels. There was a study that was done by a group in Mexico, and it's Isabel Remieux is here, the lead author. It was a randomized field trial in which biomass burning improved stoves were installed in homes versus just keeping a traditional stove. This is about 500 women. Even though the adherence to the intervention was low, one of the findings that came out of the study with a short follow-up, it's about a year of follow-up, was the use of an improved stove was associated with a lower lung function decline. It decreased the lung function decline from the 60s, 60 ml per year, down to about 30 per year. But this is somewhat controversial because there are other researchers that have not seen this. There's another group in Mexico that looked at a group of about 500 Hispanics who either had tobacco or biomass associated COPD, and they were followed for 15 years. And what was interesting is one of the things that they see is that there was a slower FEV1 decline in biomass COPD than in tobacco COPD. And there was also less heterogeneity in their FEV1 decline. The study that followed Respire, there's a field, it's called CRECER, it's like a follow-up of women who were intervened during Respire. This is a 5-year follow-up. They also were not able to find any difference in lung function decline between the intervention and the control group. So here there are a couple things that it points out to. One, could it be just like cigarette smoke, where there's a potential gene by environment interaction, so not everybody's affected? And the other is just bringing it back to that hypothesis that Lang has put forth, which is that it could be that biomass smoke, fuel smoke, is affecting you reaching your full potential. And that in itself could be that you have much less lung function to lose, and that's why it's a slower rate of lung decline afterwards. Wanted to be able to also share some of our lessons learned in Peru. We conducted a longitudinal cohort study in Peru in which we did lung function at baseline and then longitudinally for 40 months. It was a study that was done in 3,000 participants. We conducted this study in 3 settings. 2 of them were at sea level, Lima and Tumbes, and 1 of them was at high altitude, Puno, which is about close to 4,000 meters above sea level. And if you want to contrast kind of differences across these settings, Lima is the highly urbanized capital in Peru. A lot of traffic, a lot of ambient air pollution exposure, but little in the form of household air pollution from biomass smoke in our communities where we work. Tumbes, it's kind of an idyllic setting by the ocean, mostly fishermen and farmers. Most of the cooking is actually done outside because it's a little bit too hot to cook inside. And then in Puno, we broke it up into an urban setting, very similar to Lima, and but lower population density. And then rural Puno, where cooking occurs exclusively inside because of the weather. It gets to be quite cold in Puno. So we also had an opportunity in a subset of these homes to look at what were the household air pollution exposures. And here is a figure of household PM. Here you have kind of calendar time, and this looks minute by minute, and we were able to look at pollution data on a minute-by-minute basis using a nephelometer, kind of a real-time pollution monitor device, and we calibrated it against kind of the standard gravimetric approach. And here what you can see is very different profiles across our geographical settings. In Lima, there's a good amount of levels of pollution that go throughout the day, which is highly indicative of ambient air pollution. I think the average ambient air levels of PM 2.5 in Lima range anywhere from 20 to 40. Sometimes they can get up to 80 micrograms per cubic meter in the summer. Tumbes and rural Puno are the places where you cook predominantly with biomass fuel smoke, but you can see here that in Puno, where it's mostly cooked inside, you can see these higher exposures. So, and this was kind of quite similar in another smaller subset of homes in which we did an evaluation of particulate matter and carbon monoxide in urban and rural households, and you can see kind of these levels are quite similar. But when we looked at COPD in our settings, we see that the overall prevalence of COPD is around 6%. It's quite similar actually to the U.S. One of the important differences with the U.S. is that cigarette smoking is actually quite low. Daily cigarette smoking is on that average of like 1 to 2%, and with a very low level of pack years in general. And it's across all our settings. Probably Tumbes had the highest level of daily cigarette smoking. But overall, you can see that values in urban centers stayed around 6%, and in a rural setting where biomass fuel is used daily and inside the home, it's about 10%. Tumbes is quite low, and part of it is too because very very little cigarette smoke exposure, and also biomass fuel smoke exposure is also low because most people cook outside, And as they say, kind of the solution to pollution is dilution. I think that's a good example there. We went ahead and also looked at population attributable risk factors for COPD by sex. And one of the things that we found based on our data is that when you looked at women, about 50% of COPD was attributed to biomass fuel smoke exposure in women in our setting. Similar to others, we found that chronic bronchitis was also quite, was associated with double the odds, biomass fuels double the odds of having chronic bronchitis. Interesting enough, urbanization itself was also linked to your odds of having chronic bronchitis, such that it almost tripled the level of chronic bronchitis, and this is predominantly kind of in our setting in Lima. So when we went ahead and looked at our lung function decline data in our settings, it's actually quite similar to what you expect in other settings. Kind of the average values are somewhat around 30 mLs per year, and with a good amount of variability across the settings. But in multivariable regressions, which we adjusted for multiple factors, one of the things that we found out that biomass fuel smoke was associated with an accelerated decline of about 4 mLs per year in forced vital capacity. And this somewhat, if you kind of look at the overall, this decline, it represents about 15% of the, an additional 15% decline in lung function. In an early trial that we had a chance to do with kind of installing improved stoves that it was still kind of biomass burning, we went ahead and did this in 3 settings, in Peru, in Kenya, and in Nepal. It was like a population of about 120 participants, and this kind of preceded some of our ongoing household air pollution trials. Here you can see that the traditional stoves are pretty similar across the different settings. And the 2 types of stoves that we installed, one was a commercially made stove by EnviroFit, which is actually a single stove, a rocket burner that had a support with a chimney, and then we were able to construct this like locally made stove. And one of the things that we found is that here we collected lung function monthly. And we looked at FEV1 and peak expiratory flow. Here you can just see kind of the baseline values of PM 2.5 and CO in relationship to outcomes. I put the wrong slide. I should have just put the peak expiratory flow slide. But in general, one of the things that we found is that there was a kind of an important difference in peak expiratory flow. There was an improvement in peak expiratory flow in the homes that received improved cook stoves compared to baseline. But one of the things that I think has come out, and many of you have heard this, is that was the reduction sufficient? So here, this is the kind of the pre-intervention period, and here are kind of these are also minute to minute. This is actually summarized in hours, kind of the proportion of minutes within that hour that you are kind of these different levels of exposure. And it was not unusual to find levels of like high proportion of minutes within an hour where exposures were as high as 1,000 micrograms per cubic meter. But if you actually notice, like in periods 2 and 3 compared to period 1, you don't see much of a difference in terms of what the intervention actually did to lower peak exposure rates, even though the mean exposure rate was reduced by about 50% across our settings, which indicates that whether there was like either stove stacking, people were using their traditional stoves in addition to the improved stove, or that the improved stoves were actually not working to be able to reduce the exposure at a minimum. And I'll briefly go and I'll finish with these other environmental risk factors. You know, in our multivariable analyses, 2 things of our Chronicas data, 2 other factors came out to be important. One of them is that we could see that people who lived in urban centers had an accelerated lung function decline, and so did our population who was at high altitude. So again, I think in our setting in Lima, you can see that there's the profiles of pollution exposure are significantly higher than in kind of other settings. And this could potentially explain kind of the reasons why we're seeing accelerated lung function decline in our urban settings. The other thing is that one of the things that we've become very interested is also understanding the role of hypoxemia in the development of chronic diseases in altitude settings. One way by which high altitude could be associated with accelerated lung function decline could be through the kind of the role of this low-grade systemic inflammation that appears to be associated with hypoxemia. Here you can see this is the mean oxyhemoglobin saturations across our settings. I think in our high altitude settings, the average is around 90%. And if you actually look at high sensitivity C-reactive protein differences between both, you can see that levels of oxyhemoglobin saturation below 85% were associated with higher levels of CRP and compared to higher values. So this is basically what I'm saying here. And finally, I'll end up with this. We had an opportunity to look at a cohort of children who were born to mothers who participated in a vitamin A intervention trial, in which mothers received low dose vitamin A before, during, and after pregnancy. And then we're able to follow the offspring 9 to 13 years later and see kind of the effect that they did on their lung function and size. And one of the things that we found out is the group of children who received, whose mothers received vitamin A had improved lung function, improved lung size, higher levels of FEV1, even after you adjust it for multiple things. And this kind of brings back the point as to the importance of the in utero environment in lung function and development. So just kind of as a summary, biomass fuels have been associated with accelerated lung function decline, but we need better studies and doing randomized controlled trials to better understand the mechanisms of this. Urbanization and living high altitude and nutritional deficiencies also contribute to lung function decline. And all these exposures begin in utero and are present through the life course. Well, thank you.
Okay, we can take one or two questions. So Professor Chuckley, yes, please.
Yes, a couple of comments. One is the people exposed to biomass differ in several things from the people that are not exposed. One is the poverty, for example, and for example in Peru, the higher the altitude, the ethnic composition may also change. That I think is missing in your last list. This that's why intervention trials can be especially important in this issue. And the other comment, the increased drop in FBC will not lead to airflow obstruction. So I wonder if, with the epidemic of obesity, or I don't know what other factors you consider for this increasing decline of FBC.
Well, thank you. So coming to the point of poverty and ethnicity, I agree with you. I think poverty is an important driver, and we know that socioeconomic status is an important driver for COPD outcomes, in particular, just having COPD or even potentially the development of COPD. Ethnicity, in our study, there are important ethnic differences across all our settings. I think ethnic composition in Lima is actually quite different from that in Tumbes, I think, and in Puno. So we've done ancestry informative marker studies comparing Lima and Tumbes. We see important differences. We haven't done that in Puno, but I think there are quite important phenotypic differences that occur in terms of anthropometric structures that could explain differences in lung function. So I think that's also an important factor. I think we've had a chance to compare urban to rural Puno, which have similar ethnicities, and the findings are robust within those groups. In terms of FVC, kind of the drop in FVC and not why in FEV1, I think that's also an important question. I think your research has shown that a lot of what happens in the lungs is actually is scarring. You see a lot of fibrosis, which is inherently linked to your vital capacity, your forced vital capacity. So not only are you getting obstruction, but you're also getting restriction when you get biomass fuel and smoke and exposure and damage. We've had a chance to look at cigarette smoke and BMI as well. We're actually in the midst of finishing up an analysis. We were able to join several cohorts across our with our colleagues to look at the relationship between BMI and COPD outcomes. We have close to like about 12,000 individuals, all in low and middle income country settings, and are looking at the questions that you've brought up. So thank you.
Thank you. Unfortunately, we have to move ahead because of time constraint, and we will leave the questions to the end of the session.
Yeah.
Thank you very much.
Thank you.
Our next speaker is Dr. Sinwan. He is known to most of you.
Oh, yeah. Thank you. Thank you, Asma. Good afternoon, ladies and gentlemen. It's my honor to be here to share with you some experience and observations about air pollution and the risk of tuberculosis. I would like to talk on two subjects. One is focus on indoor air pollution, and the second is ambient air pollution. We focused on that issue was back to 2007 when I was leading the Lung Health Department of the Union. At that time, our WHO colleagues talked about the risk factors of tuberculosis and showed that both tobacco and air pollution has high population attributable fraction for the global burden of tuberculosis. So we think it's important to come up with a clear evidence whether the association between both indoor air pollution, outdoor air pollution, and tuberculosis are clear or not. And if the evidence is clear, then that should lead to action to reduce the exposure of populations to both in pollution. So we begin with the indoor air pollutions. Those are the fuels that people use for cooking and heating that being classified either as a non-solid fuel or solid fuel. And those, we know that they are not the same. Some of them has high efficiency in generation of the energy, but the solid fuel are not so efficient. And also, when they use a solid fuel, it also has a lot of air pollution. And we know that it's mainly in the developing countries they use solid fuel for cooking and heating. And you can see the percentage is mainly in Africa and also in Southeast Asia and Asia Pacific regions. You have a very high proportion of the populations they are using solid fuel for either cooking or heating. This is the global burden of disease, talking about the risk factors. You can see that the leading risk factors include both the household air pollution from solid fuels as well as exposure to ambient particulate matters pollution. So both are very important risk factors of global burden of disease. And we go into the detail, you will see that the different outcomes of the exposure to air pollutions that will include a lot of things, including cancer, including cardiovascular disease, COPD, cirrhosis, many things. But then you may wonder what about tuberculosis? And you will see that in fact there was no tuberculosis being included in the global burden of disease when it comes to the air pollutions. So perhaps the burden of the global burden of disease related to air pollution has been underestimated if in fact there's association between air pollution and tuberculosis. So it's important to look for evidence. We begin with the systemic review a long time ago that we published in 2010. At that time there was only 6 articles being identified, and then in the review we find there was no clear evidence to show an assessed risk of tuberculosis due to exposure to indoor coal or biomass combustion. So we decided to have a study by ourselves and we designed a questionnaire, and then we did the matched case control studies in 2 countries, one in Benin and the other one in China. So here is one article that we published on European Respiratory Journal. You can see that we have 1 case and 2 control. That control mainly selected from the neighbor of those tuberculosis cases. This is distribution of the fuel that they use. You can see that the majority in these countries, they use charcoal. And this is the distribution. You can see that there's very high proportion, both cases and control, they use solid fuel for cooking. And we use the graph from the Prevalence Survey of Tuberculosis published by World Health Organization to ask the people what kind of stove that you use and to collect those informations. So this is kind of some examples about open fire, and this is the improved single pot, and then the people go for data collections, they come back and show us that, for example, in Benin, you can see that the majority, high proportion of populations, they use the improved single pot for their cooking. But it's also important to look into the location of cooking, because that has the result in a different intensity of exposure. In Benin, you will see that quite substantial proportion of patients, they cook outdoor, but also there are some of them, they cook inside in a separate room or in separate buildings. Only small proportion, they cook in a room used also for living and sleeping. This is the univariate analysis. You can see that, and the odds ratio was significant, but also pay attention to smoking and the household contact of tuberculosis, quite high. The odds ratio is very high in univariate analysis. When it comes to these conditional logistic regressions, the association between the use of solid fuel for cooking and tuberculosis become not significant statistically. And then the significant factors are smoking and the household contact of tuberculosis in past 5 years. So that was the finding in Benin. In China, you can see that also the high proportion of both cases and control, they have used solid fuel for cooking. And smoking, also high proportion. This is related to the type of stove that they use for cooking. In China, in the 1970s and 80s, there's a big program to improve the stove for cooking. So you can see the majority use quite a better stove as compared with Benin. Location of cooking, again, a high proportion they use in a separate building for cooking. So in overall, 92% of cases, 92.5% of control, they have smoke removed by hood or chimney. This is the univariate analysis. You can see that in China, in Anhui, the solid fuel for cooking, in fact, is not the association between this solid fuel cooking and tuberculosis is not significant. The significant factor, remember, is smoking, and then again, is the household tuberculosis contact. After that, after a few years after that 2 studies, we decided to again to repeat the meta-analysis, same review and meta-analysis. So this is the flow chart diagram of the review that we published recently. You can see that there's a high number of literature that we search, and then we come up with 15 studies, and we assess the risk of bias of all the studies that we review. And you can see that the case control studies and these cross-sectional studies, the green one is low risk of bias, the yellow one is unclear, and the red one is high risk. So you can see that, in fact, by different elements, you can see there's a risk of bias. And also for cross-sectional studies, even higher. The more higher proportion of studies, they have a risk of bias either related to exposure assessment or outcome assessment, and also confounding. Then you can see that for the, we use the control enhanced funnel plot, and also the funnel plot, we did not detect any publication bias. The result overall, we separate case control studies and cross-sectional studies, and you see that both are not significant. And this was published in 2014. Also in 2014, we see that there's publications on the same subject. In this particular review, they report that they identified 12 studies, and overall, the pool effect estimate was significant in this study. But you can see that, in fact, there was a significant heterogeneity between studies. And the effect was higher in this study among women as compared with both genders being combined. Another meta-analysis also report that they have 13 studies included, and they use the fixed effect model, and then it was significant. So there are 3 meta-analysis, and the result was not consistent. And we published editorial to discuss these issues. I think it's important to understand that although systemic review can be useful tool for summarizing evidence to see the forest, but it may not always offer unbiased estimate of interest. As study selection, data extraction, or statistic analysis might be inadequate. That would result again in bias. So meta-analysis should be more than just a mechanical process. This should go beyond that, not just to pull studies together to come up with a single number. In fact, if we see a high substantial between study heterogeneity, the exploration and explanation of the heterogeneity observed might be more informative. So in the studies, we saw that, in fact, this is a major issue, this inadequate assessment of exposure. And then, because the concentration of those pollutants from burning of those solid fuels depends on the type of stop use and also the location, and those things are not yet really been taken into account in most of the studies. And up to now, there's no direct measurement of exposure to pollutants at the individual level or at the environmental levels when it comes to the study on indoor air pollution and tuberculosis. So there's room for improvement. Perhaps we can also think about the study populations. Like children, should we focus on children? Their review on the childhood TB and the exposure to indoor air pollutions, and then they find almost very few studies to come up with any conclusion. And also perhaps there's difference between male and female, because in most countries perhaps it's mainly female who was cooking, doing the cooking at home. So in this particular study published recently, they found that in Pakistan, in fact, among female who cook at home, and they have they find association between indoor air pollution and tuberculosis. So perhaps there's something for us to do in the future. Now a few slides on ambient air pollution and tuberculosis. This was published some time ago. No, this was a new one, sorry. This is published in 2016 from California. They showed that there's a positive association with ambient carbon monoxide and NO2 and tuberculosis. And this is a study from Korea. The finding was not consistent. You can see that the concentration of different pollutants, they are not associated with tuberculosis. But then the increase of this SO2 concentration was associated with tuberculosis. We did a study in Taiwan. We use the study population include participants who participate in a community-based integrated screening program in New Taipei City. And you can see here, this is the number of participants in the screening program. And then we, the exposure assessments include the particulate matter PM 2.5, PM10, as well as also carbon monoxide and nitrogen dioxide, and also ozone. And because there's several stations who monitor the quality of air, so we use that as the got that data and to measure the exposure of populations and tuberculosis patients to these ambient air pollutions. So here's the map. You can see that this is a monitoring station in each red spot, and then these individuals we included in this program, and you can see this is also the population density by the different type of color. We use the Cox proportion to estimate association between ambient air pollution and tuberculosis. For each individual, we calculate the annual relevant exposure level using the average levels of air pollution in the preceding years. So it's time dependent, and also we change the exposure from time to time. And the effect of air pollution was modeled linearly at each 10 microgram cubic meter, different ways to measure those exposures. And in addition to that, we also estimate the road intensity as a proxy of the traffic-related air pollutions. We measure the length of roads within the 500 meters buffer zone around each residential address. And after 6.7 years of follow-up, we got 418 cases of tuberculosis, and you can see here exposure to PM 2.5 was associated with increased risk of tuberculosis. In addition to that, the traffic-related air pollution, including nitrogen dioxide, nitrogen oxides, and also the carbon monoxide, is also associated with tuberculosis in this particular study. So in summary, the household air pollution from solid fuel and exposure to ambient air pollution has been the leading cause of global burden of disease. But perhaps if tuberculosis is also related to air pollution, perhaps the burden of disease has been underestimated due to air pollution. And then for the evidence that we have, in fact, we do not have high quality of evidence, so it's important for us to think about how to improve that, the quality of evidence. But the lack of high quality evidence between the association, on the association between indoor air pollution and tuberculosis does not mean that there's no associations. And then from the study that I just showed to you, perhaps the evidence on the association between ambient air pollution and tuberculosis is increasing. So perhaps now it's time to, again, try to come up with high quality studies so that we can really clarify the association between air pollution and tuberculosis, and also to estimate the impact of the problem. Thank you for your attention.
Can I just talk? Can I ask you a question? Hello.
Yes, yes.
Kevin from Liverpool. A nice summary. I think just a couple of observations. I guess one big problem in this area that you've nicely described is that use of solid fuels or use of dirty burning fuels or exposure to household air pollution or exposure to outdoor air pollution or exposure to the risk of tuberculosis are all entwined with poverty. They are all arguably markers of poverty. And so I think one of the problems that you've nicely described, that you can't pick out a signal when you're looking at any of these exposures compared to the outcomes, probably relates to that common issue of they're all markers of poverty and they can't be disentangled unless you do a randomized controlled trial in that context, and you maybe take out all of that noise and major effect of poverty.
Yeah, thank you. This is really crucial. You know, when we design the match case control study, that is one of the key issues that we try to address, but it's difficult to measure. So then when we think about how to select control, we think perhaps if we select neighbor, they live together in the same area, perhaps the socio-economical status might be the same. So that's the reason we select, those who live in nearby as control. But then we also face a difficult challenge. You could go to the communities, you can see that if one house is cooking and the whole area, perhaps they face the same issues because those pollutions will just go from one household to the other one. So these are issues perhaps not easy to disentangle. So I agree with you that a control trial might be useful, or perhaps really to go to measure the exposure level intensity either in the environment or the individual level.
another thought is, Will gave a nice talk about COPD and chronic bronchitis, and I think although I might not completely agree about the evidence base in terms of the COPD link with biomass smoke exposure, I think that the chronic bronchitis story is quite compelling. And certainly, if you go and talk to people who use open fires, they complain a lot about coughing. And so, given that a major factor in terms of TB transmission is coughing, perhaps there will be something important in that biomass chronic bronchitis TB transmission story.
In fact, this is quite, I see, because I saw that our colleague from Mongolia was here, but now they left. It's perhaps it would be useful to think about the unique environment like in Mongolia. I went to Mongolia, I was always amazed by that environment. In Mongolia, during the summertime, the temperature can go up to 20, 25, But then in the wintertime, like from October, November, the temperature dropped below zero. And then in January, it's minus 20 or 30. So everybody stayed in the same room. And then Mongolia has a very high seasonality of tuberculosis, very high. And then they also use in the traditional girl, they also, cook inside. So there's air pollution, there's tuberculosis, there's coughing, and there's delayed diagnosis, and result in transmission. Also, everything are entangled. So it comes together. So might not be easy to really to see what is going on. Like the study that we did, there are two studies, always show that the household contact of tuberculosis is the most powerful risk factor, followed by the next subject is smoking. And indoor air pollution, ambient air pollution, up to now we are still struggling how to get a clear evidence.
Well, thank you very much. And I think, Kevin, you brought up a good point for discussion after our last presenter that we'll have to come back to. But now we have Professor Neil Shugler from Columbia University, who will be presenting on smoking and air pollution, the new social determinants for tuberculosis.
Thanks, Will, and thanks, Dr. Alsoni. Thanks to the organizers for inviting me. I'm actually going to say very little about air pollution because I think it's been very well covered. I'm going to talk a little bit about social determinants generally, and then quite specifically about cigarette smoking. Social determinants of health is a phrase that gets thrown around quite a bit, but I thought I would just try to define a little bit about what we're actually talking about when we say the social determinants of health. This is one schema that has kind of organized the social determinants of health into these 5 domains that you can see: economic stability, education, social and community context, health and the availability of health care, and then one of the themes that really has organized this session this afternoon, neighborhood, but more importantly, perhaps the environment, including the built environment in which people live. So this is what we're talking about, I think, when we talk about the social determinants of health, and I'd like you to think about how these things affect tuberculosis in particular. And I'll start by giving you an example of how important social determinants of health can be for tuberculosis. These are 2 landmarks in the history of tuberculosis. These 2 papers on your left is Robert Koch's original description of his discovery of the cause of tuberculosis, his discovery of Mycobacterium tuberculosis. That paper was published in 1882 in Germany, and on your right is another landmark, not just in the history of TB, but in the history of medicine, the first randomized controlled trial ever published in medicine. This was the streptomycin trial, demonstrating that antibiotic therapy of tuberculosis was, in fact, effective. And so this was on the left, 1882, on the right, 1948, so some 60 years in between the identification of the cause of TB and the first introduction of antibiotics. What I want you to think about, though, is this, which shows you what was going on in many parts of the world in that period between the identification of the tubercle bacillus and the introduction of antibiotics. You can see here that in many parts of the world, deaths from tuberculosis were going straight down. This is a time, remember, there was no treatment of TB available. The data on the left are from New York City, deaths from pulmonary TB and pneumonia, and we heard a very nice talk about some of the environmental impacts on that. So death straight down, and the same thing, this is England and Wales. a very similar trajectory, deaths from TB going straight down, aside from these interruptions for the First and Second World War. War is dangerous for children and other living things, and you see that here. But the striking thing about this, as I mentioned, is that death from TB declined very steeply and very sharply at a time when there was no treatment for TB available. So what was going on at that time that contributed to the high incidence of TB, and what changed over the ensuing many decades that led to the decreases in TB? This is just a photograph taken about the same time that Robert Koch made his discovery. This is a boarding house in New York City at the end of the 19th century, the beginning of the 20th century, and you can see that these sorts of conditions would certainly lend themselves to the spread of TB. You have a very small crowded space. There are at least 1, 2, 3, 4, 5, 6, 7, and I think 8 people in a very small place that has no ventilation, no sunlight, probably a cook stove that's adding to the pollution in that room. Same thing, a very similar situation. The windows here have been boarded up. There's lots of people here. There's a wood-burning stove, very little ventilation. So so we think of conditions like that as being associated with an environment in which tuberculosis was likely to occur and likely to spread for all the reasons that you've heard in the preceding talks. And to the extent to which conditions like this improved around the world, that probably contributed significantly to the decline in TB deaths that I showed you a moment ago. But it doesn't disappear, and anywhere in the world at any time, conditions like this might still occur or could return. This is a photo. I usually show this photo without the tagline here in the beginning because this looks like something out of Dickens, in the 19th century in England, but this was a large homeless shelter in New York City only 25 years ago, and so you can go anywhere in the world occasionally and still find these sorts of social conditions, right? You have an enormous homeless epidemic in a city, and you take those people and you put them in shelters where people are very close together. There is very little ventilation, very little sunlight, and you have spread of tuberculosis. These are some photos I took in Addis Ababa, where we have a project, and you see again, housing in some of the urban slum areas where there's very crowded living conditions, very little sunlight, able to get in, and poor ventilation. And so, as was pointed out in an earlier question, and Kevin's remarks just a moment ago, the social conditions which are not only poverty, but social conditions, have an enormous impact on rates of tuberculosis. I made this graph a few days ago using data from the Global Burden of Disease Project. You can go on their website and have lots of fun with the data, but this just shows you the tuberculosis case rate per 100,000 persons in different regions of the world, separated by something called the socio-demographic index. This is an index that's used by the Global Burden of Disease Project that integrates three things: gross national income per capita, more or less, educational attainment, and fertility rate. And so they integrate those into something they call the socio-demographic index and separate regions of the world according to SDI levels. And it's regions of the world, not necessarily countries, right? So there are, for example, in China, there are parts of China that are high SDI regions and parts of China that are low SDI regions. So this index actually is able to discriminate to a fairly fine level, and certainly better than a national level, can discriminate at a subnational level. And you can see that if you separate the world into these SDI regions, that the lowest rates of TB in the world are in high SDI regions, places where there's basically high gross national income per capita, high levels of educational achievement, and lower fertility. And then the rates of TB just really go straight up as you go down on the scale of socio-demographic index, right? So as I think questioners from the floor have pointed out before, this has an enormous impact on rates of tuberculosis around the world. Now, obviously, there's mechanisms here that we have to understand, right? It's not enough to say that we just have to put everyone in a high SDI region and TB might go away. I mean, maybe that would happen, but I think we really want to understand some of the mechanisms that are responsible for this effect of socio-demographic index on TB rates. part of the TB world recognized this a long time ago, the influence and importance of these sort of factors, and part of it didn't. And I'll just show you, this is sort of fascinating to me. Selman Waxman won the Nobel Prize in 1952 because he discovered streptomycin. And when he won the Nobel Prize and accepted it, he gave a lecture, as all Nobel Prize winners do, and this is what he said. He said, well, by 1952, isoniazid had also been discovered, and then Waxman said, well, now we have, isonicotinic acid hydrous, isoniazid, INH, and we're going to combine it with other antibiotics. And so he said the conquest of the Great White Plague, that is TB, undreamt of less than 10 years ago, is now virtually within sight. So that was in 1952. Waxman said, TB's going away, right, because we have antibiotics. The same year, René and Jean Dubose, who were scientists working at Rockefeller University in New York, published a book called The White Plague. If anyone who's interested in the history of TB should read this book. So they, in the same year that Waxman said TB's going away, they said, forget about it. However useful in specialized cases, vaccination, antimicrobial drug therapy, or other therapeutic measures cannot possibly solve the social problem of tuberculosis. Tuberculosis is not going away till we solve the social issues around tuberculosis, what we call today the social determinants. So they were, of course, right. And Waxman was optimistic but wrong. And so we've discussed in the prior talks already some of the social determinants of TB, poverty, malnutrition, overcrowding, which can occur in housing, workplaces, prison shelters, and refugee camps, and those all have important impacts on TB rates around the world, have to be addressed. And we've heard just now about the impact of biomass fuel use on TB risk specifically, and lung function generally, and ambient air pollution from automobiles and industry. But I want to focus a little bit now mostly on this, on the role of tobacco. This is meant to signify the impact of diabetes on TB risk. I'm not going to talk about that, although there's considerable evidence now that diabetes is a significant driver of TB risk in many places around the world. But I do want to talk about the risk of tobacco because, as my colleague Chen Yuan pointed out, there's very solid evidence that cigarette smoking at really every step in the natural history of TB increases risk for TB. So here is one study that points out that tobacco use is associated with a higher risk even of developing latent tuberculosis infection. This is a study done in the United States using a database from something called the National Health and Nutrition Examination Survey. It's a periodic survey of Americans where they look at a whole bunch of health risks and health outcomes. And so they looked at smoking status, which was confirmed by urinary cotinine measurement. And it turns out that the risk of latent tuberculosis infection for smokers after everything else was controlled for age, gender, socioeconomic status, race, birthplace, household size, and contact with an active case of TB, if you account for all of that, the risk of latent tuberculosis infection was more than twofold increased, right, accounting for everything else. So just developing latent TB infection, smoking has a risk. Once you have latent TB infection, how much does smoking increase the chance that you're going to get active tuberculosis? These are data from a study that we did in the Tuberculosis Trials Consortium that was looking at a new therapeutic regimen for treatment of latent tuberculosis infection, but we analyzed the data to say, well, what other risk factors predicted development of active TB, and nothing in our cohort predicted the development of active TB more than current tobacco use, almost a 5-fold increase in risk, which was in this study greater than the risk of HIV infection, although the caveat here was that the HIV-infected patients we had in this study had very well-preserved immune function, CD4 counts of about 485, so they were well-controlled. But still the point is made that current smoking increased the risk of active TB 5-fold. Once you have tuberculosis, if you continue to smoke, you're likely to have a worse outcome. I'll just sort of quickly point this out, but in this study in Brazil, this is a nested case control study, done that show that persons with TB who continued to smoke were twice as likely to have delayed culture conversion, that is to say, slow to improve, even having been started on antibiotic therapy, right, over twofold. And then finally, data from Hong Kong. It's a very good TB control program. This is a study from C.C. Leung and colleagues in Hong Kong, where they looked at 16,000 patients with TB treated in Hong Kong in the government TB clinics, and looked at the risk of relapse after completion of treatment for TB, and they showed, and this is very nice because you can really see that there's a long-lasting impact of cigarette smoking. So the risk of relapse in never smokers after completion of therapy is shown in the bottom line here. These are former smokers, and then the risk of relapse in current smokers. So there's a clear, in a sense, dose-dependent effect depending on if your immune system, pulmonary defense mechanisms have suffered previous damage, but you don't smoke, it's still worse than never smoking, and if you continue to smoke, the risk of relapse is even higher. So I use these studies as signifiers to point out that there's an enormous, I think, evidence base that cigarette smoking increases the risk of developing latent TB infection, it increases the risk of going from latent to active TB, it increases the risk that you'll have a poor outcome from your active TB treatment, and it increases the risk that you'll have a relapse if you do complete therapy. So I think it's worth thinking a little bit about the epidemic of tobacco use around the world, because I think it's pretty apparent by this point that we won't be able to completely control TB if we don't think about controlling tobacco. This shows you global smoking prevalence among men, blue, green, yellow, orange, and red, increasing risks, and you can see certainly in many of the highest burden countries of the world for TB, there are extremely high rates of tobacco use as well. This just hones in on Europe, Asia, and Africa, pointing out that men smoke at much higher rates. I think everyone really knows this. In most of the world, men smoke at much higher rates than women do, the exception being Europe, where men and women smoke at about the same rate. But in most parts of the world, men smoke at much higher rates, and in certain parts of the world, again, where TB is common, Russia, China, countries of Central Asia, Southeast Asia, and into Southeast and South Asia, rates of tobacco use are extraordinarily high among men, 30 to 50 or 60% of the male population in those countries. I'll skip that for a second. But I want to make this point. If you look here, it does seem, for example, in sub-Saharan Africa, that rates of cigarette smoking are generally fairly low, and in many countries of the world that would have a lower SDI rank, rates of smoking are somewhat lower than they are in other parts of the world. But if you look at the trends in smoking and smoking-related risk for TB, I think it's quite worrisome. So again, I went to the Global Burden of Disease Project and made this graph. This shows you the percentage of disability-adjusted life years from tuberculosis that are attributed to tobacco use. Okay, you can get this data from the Global Burden of Disease country, and it's quite interesting because you can see that in some regions, particularly the high SDI regions, the highest level of sociodemographic index, where there has been some progress against cigarette smoking. So in the United States, for example, only about 14% of the population smokes. Now there's been a decrease. It's a low-burden TB country, and that's similar in many high SDI regions. So the amount of TB attributable to tobacco has decreased fairly sharply, but as you go to lower SDI regions, that decline kind of levels out, and most interestingly, I think, if you look in the lowest SDI regions in the world, these are regions, again, the lowest sociodemographic index regions, the contribution of tobacco to tuberculosis is increasing. And I think that's in part because in many low SDI regions, smoking rates have been low until recently, but now tobacco companies are moving into those low SDI regions because they realize there's an opportunity there, you know, in countries of the world that may be, relatively speaking, poor but have high economic growth rates. tobacco companies see that as an emerging market, and they're moving very strongly there. And so I think that's probably why you're starting to see this rise in the contribution of tobacco to the TB burden in low SDI regions. If you look at the percentage of the world, the percentage of the world's population that's protected by the various tactics included in the WHO's Empower strategy for combating the tobacco epidemic, you can see that the majority of the world, there's no place in the world where most people, there's no component of that strategy that is being applied to more than half the world's population, regardless of what the strategy is. The pack warnings are available and reach 47% of the world's population. But the most effective means for driving down tobacco use is taxation, and that's only being used as a strategy for 10% of the population in the world. So again, making this point that if we want to combat the TB epidemic successfully, I think we have to combat tobacco because, as Chen Yuan, I think, alluded to, estimates are that the population attributable fraction for TB attributable to smoking is probably 20% at least. And so the impact of this is really significant. So I think there are important policy implications of the tobacco-TB connection. We have to educate the public and health professionals and public health officials that TB is responsible for probably over 20% of the total, tobacco is responsible for over 20% of the total TB burden in the world. Low and middle income countries have the highest rates of TB in the world, and I think in many of those countries, smoking rates are poised to increase because the tobacco industry really is moving. I showed you quickly on an earlier slide that Japan Tobacco has just paid $500 million to acquire a majority stake in the Ethiopian tobacco market, for example. So governments and health ministries should prepare to protect themselves against the pressures that would increase tobacco use. Smoking cessation programs need to be strengthened and linked to TB control programs. And I think smoking should be added to the risk factors that we recognize for developing active TB in patients with latent infection. So if I would sort of sum up in general and say, what do we think about the social determinants of TB at the early part of the 21st century, I'd say that, there's a growing and convincing evidence base that links diabetes, which we didn't talk about today, but TB use, tobacco use and air pollution to increased risk for TB. It's likely that these risk factors, diabetes, smoking, air pollution, are increasing rather than decreasing in most parts of the world, so failure to control them will impair efforts at global TB control. This further, I think, underscores that although there's so much of a focus now on non-communicable disease, we shouldn't forget that there's a tremendous link between communicable disease and non-communicable disease. And so health systems should address the co-epidemics of diabetes and TB, of cigarette use and TB, of air pollution and TB, if continued progress in TB control is to be made. So thanks very much, and if there's time for questions, I'll take them.
Kevin again. So I think this issue of the smoking epidemic arriving in Africa is probably one of the most worrying, avoidable, preventable epidemics that is just going to happen. And it's all whilst it's been bad enough in the high-income countries and bad enough in the middle-income countries, the might of the tobacco industry cannot be underestimated. And a unique problem that many of the African countries face, and let's take Malawi as an example, is that they grow the stuff and they need the money from the tobacco companies. It's a major cash crop for them. Without that, they are have got even less than they, So they're kind of trapped. Not only can the tobacco industry manipulate the local markets because of the might they've got, they can sell single sticks of cigarettes. They go into partnerships with the governments to, manufacture cigarettes. But also the economy of many individuals and communities and countries are dependent on this stuff. And I think that's something that's not being taken on.
Yeah, I agree totally. I think, as I said, I think it's an enormous problem. Tobacco companies have essentially unlimited financial resources. it's astounding to think how much money they have access to, and they use it in every possible way, both legally and illegally, to create markets for themselves and get people to use them. So yes, I think particularly in Africa, this is something that is going to deserve a lot of attention. No, point's well made.
Well, thank you. We are... So we're at 3:30, but we thought we could have at least 5 minutes of discussion, given that we're talking about air pollution. Are there any burning questions? Yes, right here. I think there's a microphone right there.
So my name is Caroline Ochieng. I'm a research fellow at Stockholm Environment Institute. There's a question I missed asking from one of the presentations, which showed that a lot of, I think, health effects from biomass smoke occurs from exposure in utero. So then I didn't understand how, say, when you design a randomized control trial with a clean cook stove or fuel, then how do you separate the effect that happened? So say a 40-year-old woman who's been cooking for the long years, how would there be change?
So I think that's a great question. I think, as I said, I think in that figure, it's still, there's no evidence right now, but it's one of the potential risk factors that if you have biomass fuel smoke exposure in utero, it can have effects in growth in children and also in organ development. This is very similar to what we know, and there's good evidence for this with smoking during pregnancy. And how smoking during pregnancy has important effects in the child's birth weight and also in growth outcomes. So I think this is an area that has to be investigated and better understood.
My question is, how do you get to the point where you can then prove it, say, exposure occurs, like for a lifetime?
Well, I think, so one of the potential approaches would be to target pregnant women early on and use interventions that lead to kind of clean air. Let's say you can use a cleaner fuel like LPG to be able to reduce the household exposure. And if you do it early enough during pregnancy, and maybe that you can actually capture or the reduction in household air pollution can have effects in utero. So it could be that some of these mechanisms are kind of epigenetically modified. So like it could have, even though the exposure in the woman has happened for many decades before, during the kind of the pregnancy period, it could have an important effect. But Kevin, I think you had brought up a point that you said that in terms of, and I'm going to put you in the spot, since you did bring it up. So what was your question about, or what was your point about, the kind of these pro and cons between biomass and COPD? I think this could be kind of a good time to also discuss it.
Thanks for putting me on the spot. So I guess it's said that something like 1.5 million deaths of the 3 or 4 million deaths a year due to household air pollution is down to COPD. When you actually start to drill down into the details of those individual studies, you see a big problem. And the big problem is that almost all of them have not studied what we would recognize as COPD. They have not, it's a chronic cough, it's chronic bronchitis, it's a doctor diagnosed, it's a label, it's not generally international standard post-bronchodilator spirometry, on which a diagnosis that, So I think there's a big problem in terms of the definition of the case. And then, in common with I think the talk we had about TB is the definition of exposure, that often again is a bit weak. It depends on often questionnaire assessments. So I think when I've looked at the detail of those studies, I'm not convinced that the entity that's being studied in most cases is what we would recognize as COPD, but quite possibly is other conditions, such as chronic bronchitis without airflow obstruction, or perhaps this low FVC phenomenon that's being observed in many places in Africa. So that's what I was kind of getting at.
Oh, thank you. Rohel, you have a comment about that?
Well, I agree with Kevin. It's easier to find association between chronic bronchitis and biomass smoke, but not so easy to find association with airflow obstruction. But that doesn't mean that the women are healthy. You know, there are other diseases than COPD as defined today with an spirometer. So, but that's the situation at this moment.
Well, thank you. So it sounds like misclassification of outcome, making sure that we're using the correct definitions, and not even, there's that controversy between the fixed cutoff and the one that's based on the lower limit of normal. And then you have issues of misclassification of exposure, which are huge in most household air pollution studies as well. So thank you.
Just a comment on bronchitis. I think this is a very important area. In our small study of 50 women, where we wanted to look at airway cells, we had to exclude 20 because they had so much bacteria from their induced sputum that we couldn't see anything. And they reported they were fine, their lung function was fine, but almost certainly they reminded me of what we see in pediatrics, a persistent bacterial bronchitis, which is this sort of host, presumably a host immune defense issue, which responds to very prolonged courses of antibiotics such as azithromycin. But it did remind me very much of that sort of population.
Great, thank you. Well, I guess, yes.
I'm going to make a commercial plug, and I have a conflict of interest that I think it's very important. One is the next session in this room, you'll hear some of the same people who were asking questions and talking about air pollution. Only the issue is cook stoves and what we've learned. So I encourage you to come. Also, we have an air pollution and lung health working group that will be meeting in Cabanas 2, I believe it is, at 5:45. So if between this session and the next session, you're convinced that air pollution is an important issue for union members to be involved in, then I would encourage you to join that group. You could come to the meeting, or you could just sign on to the Air Pollution and Lung Health Work Group. So, thank you. And thanks to all the speakers.
Yeah, well, thank you.
Oh, that's the 6 to 7:30? Yeah. looks like a good session. Yeah. Yeah. Some of their data coming out of Cape Town has been super interesting with their surgical specimens and whatnot. It's very cool. All right. Very nice.